So, welcome everybody to our seventh session of this webinar series on asset management of underground infrastructure. My name is Bert Bosseler. I'm Scientific Director of IKT, the Institute of Underground Infrastructure in Europe, Germany, and I'm one of your moderators today during this webinar. Our subject today is the asset management of vegetation and infrastructure, and we are going to take a look at issues and solutions from very different perspectives. We have with us today speakers from the US, from San Diego County Water Authority in California, and also from Duke Energy in North Carolina. And we are also happy to welcome speakers from Europe, from ELA, Emscher, Lippe, Energie, that is Peter Lampret, who is next to me, and also from IKT. So this time it'll be a truly international session dealing with truly interdisciplinary topics. And to get the ball rolling on both sides of the Atlantic, I'm going to moderate this session jointly with my colleague from the USA, Bill Busch, who is representing our partner from the US, the International Right-of-Way Association, IRWA. Bill will moderate the first part of the session with speakers from the US, and then later I will take back the microphone to moderate the European part. But before we continue and introduce our speakers in detail, let's take a look how we can all participate in this webinar. Let's start. Here you can see already our speakers from the United States and Bill Busch. Now it's up to you to take over. Please share your camera and then we go ahead. So please, Bill.
Well, thank you, Bert. Can you hear me clearly?
Very well.
Okay, good. Well, this has been an exciting series of sessions. We have not only learned some very relevant technical data about asset management of underground infrastructure, but we have met knowledgeable people from around the world, other associations, and more about IKT and IRWA. With us today are several key people from the United States who serve on the executive board of the International Right-of-Way Association, the co-sponsor with IKT of this webinar. I'll introduce them before introducing our speakers. As I introduce you, please turn on your camera. So we'll start with Marianne Marr. Marianne, please say hi. Marianne is our treasurer, which then leads in 3 years to being president of the association. So Marianne probably doesn't have a camera to turn on, but she is online with us today. And there may be others that join us as we progress from our executive group. Our experts from the United States will be discussing how the management of utilities is affected by vegetation, especially trees. Starting off are Bill Rose and Vic Bianes from the San Diego County Water Authority, and they will be presenting work they have done regarding the effect of trees and tree roots on the management of large diameter water pipelines. Following them will be Glenn Winfree from Duke Energy, who will turn our attention above ground to discuss how vegetation affects the management of high voltage power lines. It might be helpful to the audience if I explain some terms and structures that are common in the U.S. but may not be well understood in other parts of the world. You may hear the term right-of-way, which is also part of the name of International Right-of-Way Association. The term right-of-way applies to a linear strip of land in which is located infrastructure, such as power lines, highways, water, sewer, or gas lines. In most instances, it is necessary for the utility owner to buy the right-of-way before installing the infrastructure. In public streets and highways, they are allowed to place their utility without buying the land, but must yield to whoever was there first. This is called a franchise right. In the United States, utilities and right-of-way can be owned by private companies like Duke Energy or government agencies like a federal, state, local, or county agency. However, a utility is owned, it is subject to laws, rules, and regulations that govern best practices for the acquisition of the property and the management of the utility. Bill Rose and Vic Bianes both are professional engineers and have worked for multiple agencies. Mr. Rose is Director of Engineering at the San Diego County Water Authority, and Vic is the Engineering Manager. I will provide a brief introduction of Glenn Winfree before he speaks in the second segment. With that, Mr. Rose and Mr. Bianes, the section is yours.
So as Bill introduced, the topic for today from the San Diego County Water Authority is managing trees in the right-of-way. Again, I'm Bill Rose, Director of Engineering here at the Water Authority, and Vic Bianes is the Engineering Manager. For today, we'll give you a little background on the San Diego County Water Authority, some of the encroachments that we have dealt with, but also, and specifically, about trees, including policy challenges, some tree species that we've done investigations, a tree root study, and specifically, as Bill mentioned, of our large diameter pipelines, and then also some design and construction recommendations that we have employed here with our facilities. For those of you not familiar with where San Diego is located, we are in the state of California on the west coast of the United States. Actually not all that far from the Mexican border. A little greater detail of where we're located. You can see us towards the bottom of the screen. San Diego is located about 120 miles south of Los Angeles. And something to note on this slide, San Diego only receives between 10 and 15 inches of rain a year. That's about 25 to 40 centimeters. And that only comprises about 10% of the water that we use in our region. Therefore, we import water from other places within California, up towards San Francisco and over towards the Colorado River on the eastern edge of the state of California. San Diego's water travels as much as 500 miles or 800 kilometers to serve our customers. The Water Authority was created in 1944 to import water to our region. We are a wholesale agency. We do not have regular retail customers, but we do have 24 member agencies who then in turn provide retail water service to the 3.1 million people who live in San Diego County. Our mission is to provide a safe and reliable water supply to those member agencies. And just for reference, you can see that we have about, in our service area, 950,000 acres or 385,000 hectares, and about 97% of the county's population lives within our service area. Bill Busch gave you a very nice definition of right-of-way, but just as a simplified one, for today, we consider a right-of-way for our purposes a strip of land that's dedicated all or in part to a public use. Some of those public uses can include roads, utilities, and railroads. And then for the right-of-way ownership, the right-of-way can be owned outright by the utility or the railroad, etc. It can also be in the form of an easement, which is a shared ownership between the property owner and the utility, or the utilities can be located within roads themselves. Right-of-way management practices at the Water Authority have become more proactive over time. Our goal is to prevent new encroachments into our right-of-way that would adversely affect our ability to operate and maintain our facilities. We've adopted a prioritization process for old encroachments in the right-of-way, and it has been very effective over the last 10 to 15 years. Interestingly, we've also had to resort to legal means, the courts, in order to remove some encroachments, and our governing board of directors certainly takes an interest in resolving those older encroachments. Some of those encroachments that we have dealt with include homes being constructed within our right-of-way, pools, swimming pools, and spas, room additions to nearby homes, significant retaining walls, a variety of other structures, fences, and our topic today, trees. Our region with so little water, when people plant trees, they definitely find a benefit of them. They increase the property values. They also have a positive effect on home heating and cooling costs. They improve water quality of our streams and ocean by reducing runoff and erosion. We're at a transitional zone from a wildlife standpoint. We have a considerable species of birds and other animals here in our county, and the trees provide shelter and food for them. Also the benefits of absorbing carbon dioxide and producing oxygen. And to be honest with you, trees are just nice looking. From a policy standpoint, the Water Authority wants to be a good neighbor with its community, and we want to balance the demands of our mission to provide a safe and reliable water supply with those of the adjoining property owners who value trees. So as you can imagine, there's considerable social and political pressure to retain trees. However, we also need to take a look at the risk and liability to the Water Authority of trees within our right-of-way that may topple and damage adjoining properties. So all of these are factors in us looking at policy-related issues when it comes to the management of trees. These two slides, these two photographs, as you can tell, were taken in 1980 and 2011. The photo on the left is of a now suburban area in San Diego County, but in 1980 it was basically vacant land with a little bit of agriculture. With the introduction of imported water, you can see now we have considerable development of homes adjacent to our right-of-way that is shown in that yellow stripe. Also schools, retail, etc. So our challenges have been to address new trees introduced by adjoining uses over the years. So at this point, I'm going to turn the presentation over to Vic Bianes, and he will talk about some of the specifics that we've done to look at the impact of trees.
Good day, everybody. Vic Bianes here. Trees have always been a concern to the Water Authority, specifically trees in our right-of-way corridor, whether it's how we deal with trees on the operation and maintenance perspective, or during an emergency, how best to remove trees to get to our facilities. In addition, we've always wondered the impact tree roots have on our adjacent facilities. I know a lot of work has been done on the sewer side, the gravity system. As a matter of fact, IKT did some extensive work on the forces of tree roots having on utilities. But not a lot of work was done associated with tree roots and large transmission mains. So we embarked on doing our own study. We hired an arborist who is an expert with trees. The arborist helped us develop a strategy and planning guideline for us to work from. The arborist shared with us that they expected to see the tree roots somewhere between 3 and 5 feet, and recommended that we look at trees, identifying trees in low topographic areas where potentially water was more abundant, and therefore a good opportunity to study the trees. This next slide shows a tree that we did target. It is a large eucalyptus tree. The eucalyptus tree is native to Australia, and in the 1800s, a gentleman by the name of Dr. H.H. Baer, who resided in San Francisco, brought the first seeds into California And believe it or not, he was a German native. The tree is known to be very fast growing, drought tolerant, and used for building materials, fire, and the oil from the trees were actually used to help identify gold particles. So during the gold rush period in California, this tree was planted throughout California, is prolific through the state today. This tree is approximately 30 years old and located directly above our 66-inch diameter pipeline, approximately 168 centimeters, and adjacent to our blow-off structure. And you can see that structure right in the center of the picture there. The blow-off structure is a structure that is used to drain our large pipeline in a safe manner. This next slide is also a tree that was selected. It is behind the yellow truck. It is approximately 125 feet tall, 38 meters. Built again or growing over our pipeline. Because of its height and proximity to electric lines, we needed to take this tree down safely. So we had crews come in and cut down the branches and trunks to allow us to get it down to the surface level. It took us approximately a day and a half to do this work at a cost of $3,500. Here is that same 125-foot tree cut down to the base trunk. We then use air spading to basically take off the topsoil to get a better understanding of the density of the root system and where the roots were traversing. In the center of the photo, you can see blue stakes. That actually is a center line of our pipeline. So this gave us a very good idea of what the roots were doing, at least at the surface area. We then used another method called water blasting and vacuum excavation. This allowed us to safely go down much deeper, following the roots down to where it would end up around our pipeline. And you'll notice here in the picture that we have a water blasting nozzle right next to our joint. We wanted to find out what the roots were doing adjacent to our pipeline joints. And you can see the vertical pipeline there is used to vacuum the water and soil materials, so we have a better understanding of where the roots are going adjacent to our pipeline. We also use conventional methods, and many of you are very familiar with this. We have a track hoe here where we're excavating around the pipe. This actually was not a very good method because it ended up taking the root system with it. So this is a very good example of seeing the roots in the center and not being able to follow what happens as it works its way down our pipeline. All of our pipelines are inspected internally 3 to 5 years by our O&M staff. The pipes are shut down and drained, allowing us to get into them to inspect the coatings and also to look specifically at the joint areas. This is a joint area, a 72-inch diameter pipeline, 183 centimeters diameter. In the inspection, we're detecting any issues with our pipeline, and to date, we have never found a tree root that is penetrated through our joint and into our system. Not only did we look at eucalyptus trees, but we also looked at trees that predominantly fall within our right-of-way. We looked at pine trees that have a deeper root system. We also looked at the laurel sumac bush. No relation to Bill Busch, but in any event, we did look at that bush, and that's a native plant that grows in our environmentally sensitive areas. We also looked at the pepper tree and a citrus tree. In all, we cut down approximately 200 trees to investigate what impact the root system would have on our pipelines. So what were our findings when we completed this study? The study actually cost us about $25,000, and what we determined is our pipelines have a minimum depth of 5 to 7 feet. The disturbed soil in our pipe trench did act similar to what was referred to as a French drain. No affiliation to the country of France. It was actually Henry French who developed this system. It's a perforated pipe surrounded by gravel, which allows us to drain the surface and subsurface area of water. So our trench actually acted like a French drain. The majority of our trees excavated had very shallow roots around the pipeline, but where there was no irrigation lines, the roots went much deeper. What we also found out is any of our pipelines under pressure, we did not see any tree roots penetrating into the joints. So we did not see any leakage or damage as a result of the roots. Our tree roots still pose a challenge during emergency repairs. As I mentioned earlier, the 125-foot tree, we needed to cut it down to get access to the base, and that took us about a day and a half. And we tried to restore services to our customers within 10 days to ensure we could still provide water to the communities we serve. And we will continue to look at implementing the tree management policy, which Bill will now get into a little bit further.
Thank you, Vic. So as we moved forward with this process and implementing, the first thing we needed to do was to do an inventory of our pipelines and determine their condition. This is an important factor since some of these pipelines are well in excess of 60 years old. That condition, then looking at how the trees would interact with the pipelines, created a rank and prioritization of which trees would need to be removed. Then we implemented a policy to go and remove those trees and to budget money accordingly. Some of our design and construction practices, which will further reduce the potential impact of tree roots on our facilities, is we install slurry plugs. This is concrete slurry mix. It's a weak concrete mix at expansion joints to reduce the migration of water in the pipeline zone. We install filter fabric in the pipe zone to stop the migration of fine soil particles into the gravel backfill of our pipelines. This removes a source of nutrients for the tree roots, and we hope that they then don't follow in and around our pipelines. We do install those subsoil drains, those French drains, to daylight at low points near where we drain our pipelines at blow-offs and pump wells to remove excess water from the pipe zone. And lastly, we do occasionally backfill our pipelines with that same slurry cement mix and further prevent root intrusion into the pipeline zone. So with that, that concludes our presentation, and we would be happy to answer any questions from the participants.
Hello, Kai Wapnans here. Can you hear me?
Yes. Okay.
Hello?
Yes, we can.
Okay. Thank you for the presentation. It was very interesting. I have a couple of questions to that, but I'd have to say I'm more from the wastewater sector than from the freshwater side. But you say there were no roots in your pressurized pipes or in the joints. Now, is this a structural thing that your materials and joints are so formed that the roots don't come in, or is it more a matter of the media itself, because you have pressurized water that the roots don't really look for that, or they look for the water that's around it that may be seeping out?
Kai, we were very concerned about what impact roots would have on our joints. And I know we didn't get into it very much, but we do have gravity lines as well as pressurized lines. And some of our facilities are in an age where there may be some cracking occurring. And we really wanted to see what roots were doing, seeking out water sources and the impact they would have on our drains. So we're very happy we didn't see any roots entering into our pipelines. So that was good for us to find out.
We also have a,
Which
well, we also have, let me follow up, we also have a variety of joint types. We have welded steel joints as well as gasketed joints. And so it's those gasketed joints that are all maybe somewhat similar to what you've experienced in the wastewater side, where the tree roots could get in through those gasketed joints. But again, we found no evidence that the tree roots had entered there either.
Thank you. It seems very successful. What types of materials do you use? You were talking about welded steel, but in your gravity pipelines, what kind of materials do you use there?
Basically, it's concrete cylinder. We've used some of that, but as Bill pointed out, we have rubber gasketed joints, so there is the potential for roots to get into those joints and into our system.
We do have a variety of different pipe materials, from welded steel to pre-stressed concrete cylinder pipe, which has a welded interior steel liner, as well as the gasketed joints on concrete pipe. So we have a variety of pipe materials. Okay.
Okay, thank you very much. Very interesting.
Thank you, Kai.
Okay, Bill, we have also one question here from Germany, and that's you've shown us that you're using liquid soils to protect your pipelines from roots, and or against the roots. And my question is, those liquid soils, you have used them to have a dense package of soil around the pipe. Is that the reason, so that no water can really get to the pipe, so that it's sealed? Is that the reason why you're using liquid soils? They are liquid during installation, but they don't stay liquid. I think they will harden out later and then will congeal. And are they a kind of sealing? Is that the main reason why you use liquid soils?
There are several reasons to use that kind of liquid soil, in essence. First is to prevent the root intrusion, but there are times when our facilities are located within roadways, and we want to be able to backfill them quickly. And so we do occasionally backfill using that material. So it's oftentimes a quick way of backfilling our facilities. It has to be done very, very carefully. But yeah, that's one of the ways that, and one of the reasons why we would use it.
I'm asking because it seems from your presentation that water is crucial for root penetration in your area. And yes. From Europe, here from our region, we know water is not the main reason, but it's the pores, the space the roots find in the soil. And water is abundant, so it's no problem to get water. So in your case, you use the liquid soils really to really seal the pipes from water. Is that the reason? And so that's the protection against root intrusion. Here we would say it's to avoid pores in the surrounding of the pipe, so that we have less space for the roots. And it's not the water that matters.
Bert, it certainly serves that function, and it's turned out to be a very handy way, a very easy way of preventing that root intrusion.
Okay. Then my next question would be, with those liquid soils, once they are hardened out, then often you get cracks when they are there's a creep or a shrinkage. You
Right.
get cracks in the soil. Is that a problem? So that then the water gets in and there's once again water to guide the roots to the pipe?
We haven't had that issue. Yes, it is a potential that you could have root intrusion through there, but I think this gets back to San Diego being a relatively arid region where root intrusion is based on where water is located. And so with the additional protection around the pipe, that it turns out not to be an issue. The roots will seek water from another source versus trying to pursue it through our either in our trench zone or from our pipelines.
Okay. Then one last question. You have shown a picture of air spading. Is it like blasting air? Is that air spading? What do you mean by this?
That's correct. It's blasting high pressure air to remove the topsoil.
Okay. Thank you.
Okay.
Okay, are there any other questions for Bill and Vic? That was a very interesting session because their work represents one of the few actual excavations of tree roots over relatively deep, large diameter pipelines. You can see through research that there was some work that's been done with smaller diameter and shallower pipe zones. That this is fairly unique research that they've done in that respect, and so it's been very interesting to see the results. Next, we have Glenn Winfree, Director of Land Services for Duke Energy, who will turn our eyes upward toward large voltage power lines. Glenn is also past chairman of the International Asset Management Committee for IRWA. Glenn, the floor is yours.
Well, welcome everyone. I have a short presentation on infrastructure, vegetation, and right-of-way issues as they relate to electric power lines. Let me get myself organized here, but I've basically divided it into three sections: some opening comments, talk about some vegetation issues, and discussing challenges and management options. Actually, vegetation management is a very broad topic that could cover days of discussion, so this will be a very brief overview, and then I'll talk about some infrastructure projects and the benefits of early getting involved early in the planning process. My presentation is going to be non-technical, and it'll talk about those topics. The information should help you get a general sense of vegetation management, how it relates to power lines, and the factors that affect the placement of power lines as they go forward. A few comments about Duke Energy. Duke's primary business is generation and distribution of electricity. Duke has over 7 million customers in the United States. The high voltage power lines on the towers that people associate with large utilities, we have about 32,000 miles of power lines, and that works out to about 51,000 kilometers. The lower voltage lines that service houses and businesses, we have about 250,000 miles or 400,000 kilometers of that type lines here in the U.S. Duke has electrical and generating operations in 6 other countries in South America and Central America, and we have a number of other businesses in the Middle East and Europe and other parts of the world. Just a few comments about the International Right-of-Way Association. This is a professional association that Bill Busch and I belong to, and Bill Rose. And I thought I'd just share a few things. It's an 80-year-old not-for-profit association, has over 10,000 members, and it serves all parts of the right-of-way industry, promoting education, strong ethics, and proper professional business practices. Its members are land agents and attorneys, surveyors, appraisers, engineers, relocation specialists, and project managers. They work for companies of all sizes: ExxonMobil, Verizon, Saudi Aramco, the City of Los Angeles, and the Japan Compensation Consultants Association, as well as many one-person type companies, many small companies over North America, Africa, Europe, Middle East, and Asia. With vegetation management, it's important to first understand the factors that make vegetation management more difficult and more challenging each year. One of the primary challenges is increasing urbanization, and there's lots of existing infrastructure, which means more and more management for a growing system, but you have to manage what you've got in place and what's been there for many years, and then you have to plan for the future needs for maintenance and expansion and operation. those challenges will continue to grow as countries and society becomes more concentrated in urban areas. This results in a higher level of encroachments, and I think Bill and Vic did a good job of talking about what those encroachments are, but they are basically the illegal use of that strip of land where the utility is located. It ends up with more damage to the facilities when people use those improperly, higher maintenance costs, so it's an ongoing challenge. Another challenge is the public opinion and public involvement. It's not necessarily bad, but it does make it more complicated to manage the facilities, the infrastructure. There's an increased societal desire for increasing carbon sinks or more green, which means more trees, more plants. People want to preserve that as an environmental issue. These higher levels of urbanization frequently lead to a more unified public opinion about certain topics, and when people get together, they become more unified, they become more active politically. And the last item on that list is increased regulation, and for better or worse, it nearly always involves increased cost and time, and this makes management of vegetation issues much more time-consuming and costly. Briefly, monitoring electric power lines and right-of-ways, and the right-of-ways where they're built, involves the use of satellites, GPS, satellite imagery, helicopters. Duke actually, the company practices to fly over to look at all high voltage lines twice a year. So every 6 months, we're flying over every inch of that 32,000 miles of power lines. We also use LiDAR, which is a combination of laser and radar, which tells us which trees are in the way and the height of their limbs and that sort of thing. It's a very, very good use of technology. There's manual inspections. I call it manual inspections. We have two-person teams, and they inspect every one of our lines. They walk all that 400,000 kilometers are walked every 12 months for a visual inspection. And of course, the high voltage power lines are continuously monitored by electrical and computer equipment. Now, sources of damage to electrical infrastructure and actually to customer business operations, the two primary sources are ice and wind. Each of these factors can damage the equipment itself, but they also damage trees and limbs, which fall and do additional damage to the lines and the equipment. Those trees falling are a primary source of power outages in the United States, and it is really not possible to protect all the facilities against tornadoes. In our area, some of the tornadoes that we deal with have winds of over 300 kilometers per hour, and we have been hit with numerous hurricanes with winds of 240 kilometers an hour plus a 20-foot storm surge. Management options for the primary risk factors for management options. The first option would be to build all new lines and relocate all existing lines underground. Now, if we have any electric utility people on the line here, they're probably having heart palpitations at this point, but this is obviously an option. It's just not a good one. The North Carolina Utility Commission, which represents the public in my state, they estimated it would take a quarter of a century to do that. If we went back and put everything underground, it would be extraordinary, hundreds of billions of dollars in cost, and it would take 25 years to complete. So that's obviously very difficult, and once those lines got underground, of course you'd have the challenges with roots that Bill Rose and the folks at IKT have talked about. Now, I've got a couple of pictures here. One shows a 100,000 volt electric power line under construction there on the left. The concrete, there will be a slurry of concrete poured in on top of that so that it will be encased in a block of concrete, and the power lines will be pulled through these tubes, these conduits that you see. And one thing I would note is that you see that with the 30-foot right-of-way, there's essentially a total destruction of plant and animal habitat. So it's not a very environmentally friendly approach within the right-of-way area. Overhead power lines, of course, would only have structures every so often, so it's a lot less impact in that respect. The photo on the right just shows a structure where the power lines come in overhead and are taken underground to the underground conduits, and they actually proceed away from you. Okay, the second and most commonly used option is just to prevent the risk of contact between trees and power lines. And of course that sounds very basic, it's very common sense, but it's very difficult to achieve. One of the most effective techniques is to simply allow more distance between the trees and the lines, and again, that is more difficult than it would seem. Property owners are very frequently aggressive, both in person and in the legal systems, about preventing tree removal and about trimming and that sort of thing. And this is a long-standing problem, challenge for power companies, but there is an approach, a way to approach this that may help resolve that, and I'll address that in a slide later on here. The other kind of a list of the maintenance-related practices is for our company, we allow people to plant trees in those strips where the utilities are, as long as we have access and the tree's mature height is less than 15 feet, and that keeps them from growing up near the power lines, which by the way, a lot of people don't realize that electricity does arc. The trees don't have to actually touch the lines. They don't have to get within a contact situation. The electricity will arc over to a tree if it gets close enough, and it will arc over to a person if they get close enough, kind of like static electricity when you touch a doorknob. Same concept. We also do more frequent mowing and to prevent the extra undergrowth from building up. We talk about trimming techniques in certain areas. We use environmental herbicides, and we actually have chemical techniques that can limit the direction of a tree's growth, and we of course direct that growth away from the power lines. And lastly, citizen education about how to use and the improper use of plantings within the right-of-way, and that topic is one that holds great potential for improvement. This slide is just a simple graphic to show how we explain it to customers and landowners for the need to keep trees back from the power line, but they're still allowed within the right-of-way area itself. The upkeep of right-of-way can be done in a lot of different ways and a lot of different standards. This photo on the left is a photo of a power line that goes through a golf course area, and the company planted some extra landscaping, planted grass, but the landowner actually maintains all this. This is much more than Duke. With 250,000 miles of right-of-way, we could never maintain this kind of situation. More likely through rural areas on the right, it's a much more environmentally desirable method. It doesn't look as pretty, but we cut material and push it over the side and let it biodegrade, and that way it's just a friendlier approach from an environmental standpoint. And here you see what happens. It may be difficult to see. I'm not sure how large your picture are, but you see a cable here in the center. This logging truck, they were going to tie down their load. They threw their cable up. It hit the line. And the reason I show this is the same thing happens with trees. Trees will fall over the line, and they will catch on fire, and they will start forest fires. They will burn houses down if they're close by. So it's a real risk, real danger situation. What I call the people factor is the source of a large percentage of vegetation management problems for us, because there are groups and individuals who are strictly opposed to any tree cutting. Most people are amenable to, or they're agreeable to talk about these things. But I will say that citizens are frequently presumed to be adversaries. When tree trimming crews go out, sometimes they feel like everybody is going to automatically be against them, and that's not necessarily the case. It does sometimes happen, but it's not always the case. I will say that politicians are used by advocacy groups and others to achieve their goals, which is to stop the cutting of trees or maybe stop the building of power lines for people whose position it is that we shouldn't have anymore. These politicized projects result in increased cost, bad publicity, delayed schedules, or canceled projects. So it's different in every situation, but these issues are almost always involved when you have legal actions and advocacy groups that stand up and want to stop a project. Citizens, if they're approached in the right manner, they will frequently be agreeable to working with clearing operations. Actually, there was a survey done in my state that said that the public would actually support wider clearing of trees for power lines if they were approached and had the right type conversation with the company. Early participation, this is kind of the last section, but early participation by people who do the operation and maintenance of infrastructure projects, if they get involved early enough in a planning process, they can help avoid or minimize some of these operation maintenance issues that relate to vegetation. The infrastructure planning is frequently done in some companies without the input of staff that will actually be operating and taking care of those vegetation issues later on. If they're able to get into the process early enough, they can help avoid or reduce potential problems in the future. On the following pages, I've put together several charts or graphics that show samples of issues that could be evaluated, and we certainly won't go through all the different items because each project will involve different challenges, and these are only examples of the kinds of issues that need to be looked at. I'll go through these very quickly. Project designs are obviously very deeply, greatly affected by wetlands. In my part of the world, we have wetlands, we have mountains, we have coastal plains, so we have a wide variety of terrains. But wetlands are a big challenge. They obviously affect vegetation management issues forever. Once the project's put in, that's going to have a big impact. What we call brownfields here are environmentally contaminated land, old industrial sites. Obviously, that affects vegetation issues for as long as you're there until cleanup and that sort of thing is done. Wildlife habitat, another issue that's affected. These conservation easements, which are tracts of land that are restricted, legally restricted from development. They're obviously a challenge in some cases. You look at the difference in public lands and private lands as far as what you can and can't do as far as plantings and trimmings. Historical sites, archaeological issues. Obviously, if you're going to be digging, if you're going to be spanning, the visual impact is certainly greater with historical areas. Urban locations, you look at smaller footprints, you look at plantings that are allowed in the city and outside for rural areas. In congested areas and urban locations, you have congestion with other utilities that I'm sure everybody on this call is familiar with, but that's one of the considerations that maybe the planners wouldn't necessarily give much weight to. But if you operate the system, it would obviously be a challenge for you from that point on. There's also, you have different challenges in rural areas. You have challenges for terrain. Excuse me, dry throat this morning. these issues are obviously going to have a big impact. Again, there's more challenges, particularly future land development. If you're going to be providing infrastructure, you need to know where your development is. You need to plan for it. You need to not be relocating your utilities because somebody didn't think about what it's going to take to operate and maintain the system. Final slide is just some things to think about. Is to ask if your department participates in the planning process, and would it be helpful to identify problems before budgets and schedules are established. These things are a big issue in my company, where sometimes teams of people get together and maybe the people who are going to operate the system didn't get invited or didn't get there early enough in the process. So that's the end of my presentation. Are there any questions? I've put my name, my email, my phone number up if anybody would like to consult and ask questions in the future. Be glad to do that.
Okay, thank you very much. But I still have one question for Glenn. And Glenn, you have shown us a comparison between underground power cables and overhead power cables. In Germany, there's a lot of discussion about electromagnetic waves and that they are a danger to people in residential areas, and that for this reason one should try to build all those new cables we need now to build them underground. Is that an issue in the U.S.?
It's definitely an issue. Lots of conversation, and I may be the only guy on the call that's not an engineer. So I'll defer to the engineers. But what I'm told is that the ground, when you put a power line underground, the ground does not act as an insulator for those electromagnetic fields. It in effect, if you have a line that's overhead, say 10 meters underground, it may be only 1 meter underground. You're much closer, and the strength of the field is much greater when you have it right under your feet versus up in the air, because the strength of the field decreases exponentially as you get away from the line, which it also increases as you get closer. Okay. Also.
So what is the depth you would usually recommend to avoid an electromagnetic field that is still dangerous? Is it 5 meters, or what is a common?
Well, there are no guidelines that I'm aware of. There's a minimum. I believe the National Electric Safety Code in the United States addresses 30 inches, which is basically 1 meter, is a minimum underground, and after that, it's based on construction. If you have a rock, if you have other utilities, the last one I did, in one place 30 inches, another place 15 feet. So it went up and down. So it had vertical curves and horizontal curves. It was not a consistent depth, and my understanding is that's the way it's typically done.
So let us start with Peter Lampret. Peter is sitting next to me and he's ready to start his presentation. Peter has a PhD in engineering from Sheffield Hallam University, and he's Director of Health and Safety, Environment and Crisis Management at Energie. ELE is one of the local energy distributors of our region here in the western part of Germany, near the River Rhine. And I hope you can see it now, so it's now your audience. Peter, please.
Oh, hi everybody. Nice to see you, nice to hear you. And I'm not very technical. I like to show you something about law and something about planning. In the past, I was in charge for planning grids for electricity, for IT, for gas. And now I'm changed the business a bit, still dealing with cables and pipes. So coming with to the first slide, just to show you where we are in Germany. And thanks to NASA, where I've taken the photo from, you see the world at night energy hotspots, and you have the yellow arrow where we are in the middle of Germany, more or less in the middle of Europe, and you see a lot of illuminated countries. And what you can see, which is also very important for planning grids, we have a partly east-west direction, but very often we have a north-south direction for the hotspots. And if you are dealing with shifting energy, many people say, let's shift it from east to west. Unfortunately, we have to shift it from north to the south. And coming to the next slide, it's a very old area, very famous. You see Egypt, you see the River Nile, you see the city, the capital of Egypt, Cairo, the white point, and you see the River Nile with illumination. So we have to shift energy from north to south, and you see also the east coast of the Mediterranean Sea with Israel. Again, we have shifting from north to south. So if we want to take solar power, for example, by the rotation of the Earth, it doesn't help very often. So and what you can see also where energy is needed. Well, I was lucky to be in Seattle last year. So I have taken some slides from Seattle last year and asked myself, what has changed by the time? In the past, we had quite a lot of ministries which are dealing with energy, economics and technology, finance, food, agriculture, for example, the farmers which produce methane by using their corn, transport and buildings, meaning energy efficiencies, environment, conservation of the nature, nuclear safety, education and research, and family affairs. So quite a lot of ministries who are involved in. And I don't know whether you know it, that we had an election in autumn of this year. And yesterday we have had the decision, and there's a new ministry for also which is dealing completely for energy. So it will be installed in December of this year, and the minister will be Mr. Gabriel. So we are hoping in Germany that we have a coordination for energy. Energy also means the grids and also the production of the energy. But going back to the past, before we had the liberalization, you see 8 grid operators, 9, and you could imagine that these are 9 bubbles. And each bubble is supplied by itself, and there were almost no connections to the other bubbles. And give you a little idea about how big is Germany. They are just, for the American friends, about 500 miles from north to south and just 400 miles from east to west. So Germany is not so big or as large as you think. It's a quite little country, but with a very high density of population. So that was a path before regulation, and we changed to regulation. And what happened? The next slide, please. So there are only 4 grid operators left. And I'd like to quote a quite famous German poet, politician and scientist, at the same time like Shakespeare was living. The spirits that I called, I don't get rid of anymore. Maybe you remember the film by Walt Disney with Mickey Mouse, the little wizard with all the water. That is what happened here in Germany with the electrical supply, with energy supply. So everybody thought about saving energies, and what have they done? They reduced the number of power stations. So many power stations are switched off, and last year they said even the nuclear power stations are switched off within the next 10 years. The second step was, as you can see, the reduction of the grid owners. And they also want to save money, and they say we optimize our grids. Optimization very often means reduction of which we don't need, and sometimes they build some bigger cables to prevent blackouts, but that is a point where we are stopping at the moment. So what has to be built, or what happened to the grids? The commercial says, well, you can't earn money with the grids. So the grids were sold, so they are almost not in German hands, and for me the grid is the backbone of the industry. They are sold to foreign companies which were looking on the world markets, where do I get very high interest rates, and the interest rates for the grids are much higher at the moment than for the money you are bringing to a bank. So as you can see, Transnet in Baden-Württemberg, it's the #1, bottom left. Maybe you know Porsche or Mercedes, where they are located. They were in the past owned by French. That's the only German transport grid. Then #2, the former Ion grid, is sold to a Dutch enterprise. Amprion, in the past owned by 100% by RWE, just 25% RCAP. This is a company which also tries to get the frequency constant. And there's another one with the grid which is sold to Belgium and Australian funds. So, and they don't have the biggest interest to invest money. And if they want to invest, they have some other problems. So, what we have to do when we want to switch off the grids, the power stations, we need new grids. And in the past, we had the production of electricity where the power is needed. So let's compare to a human body. So the head is quite close to the heart, and you have very good vessels in between for the main supply. That was the past in Germany. What they are doing now, they are building offshore parks in the North Sea. So they are putting the heart into your feet, into the little tubes, and the heart in the little tube has to supply your head. I don't know whether it can work, but there are a lot of dangers that it fails. And from the 1,834 kilometers, that's approximately 1,100 miles, just 100 kilometers are in operation, and in 2013, no new grid was built for transportation. What happened in Germany, in the North Sea? They have very big offshore wind parks. They are not connected to the grid, but the wind turbines have to rotate, so they bring some diesel or gas oil to the platforms to keep the turbines moving. So they are producing some extra carbon dioxide emissions. So you can see what has to be built in Germany. And you can see also the heart. Red are the nuclear power stations. So everywhere where we have industry, we almost have the nuclear power stations. And now we have to get the power from the renewables from north to south through Germany, and we have to find enough space. And what they want to do is, for example, within 2022, no power stations. How does the grid work? So at the moment I'm in charge I was in charge for the distribution. You see the middle, the medium voltage thing, and the low voltage thing. And the high voltage, the top of on the slide, has to be built. Electricity has, compared to gas, one very good thing. You can transform it to high voltage and low voltage. But everybody forgets that electricity is artificial energy kind. So we have to keep the frequency constant, and we have to keep the voltage constant. So when you have quite a lot of renewables in your grid, and you don't run the big power stations, the frequency can move to the top. What will happen, or what can happen, the renewable power stations, like the wind turbines or photovoltaics, are switched off. That's not the problem. But what is happening if you have switched off the big power stations like coal power stations or lignite? The frequency decreases, and then the grid is switched off. So what we are coming close is that we are quite close to blackouts because we can't keep the frequency. That's the situation we have in Germany, and we are still waiting that the bottom part, the grid for transport or transportation, the high and highest voltage, has to be increased, has to be built. So, and at the moment we are more or less a bit disconnected. Or giving you an example, almost all gas power stations are switched off. The coal power stations, most of them are more or less switched off. There are only a few ones. And even the cheapest fossil power stations, the lignite power stations of IRWA, they don't run during the week. They just run for the peak at the weekend. So I think for me it's a very dangerous thing, because the backbone, the grid is missing. So we would be happy to be able to build grids and talk about routes which can have interference with the grids. So you can see as a long lines also what I tried to explain to 2022 and to 2032. So we have to build grids through Germany. Unfortunately, the same is happening here. It was planned to build them as an overhead cable. Unfortunately, the discussion in Germany is very hard, and they don't like the magnetic fields. Everybody wants to have the cables in the ground. The estimation was 57 milliards or billion euros with overhead transmission. At the moment, it increased to, I think it was 80, more than 80, because everything has to put into the ground. And what we don't find, we don't have the space. We don't have the space for putting the cables into the ground, because we have a very high density with 85 million population in Germany. And it has an advantage to have the grid in the ground. Think about floodings. The mass can't be washed away. We have, because of global warming, very heavy local storms. We have trees on the cables. We have quite a lot of interference with them. What we did with the medium voltage, we put it into the ground, and we had less interruptions with the grid. The idea what we had then, wherever something is built in new street, we put in an empty pipe, and by the time we fill the pipe with cable. So also if the cable is damaged, it's very simple to take the cable out. It has a disadvantage to find the mistake in the cable, the failure. So showing you a slide who is involved in the process. We always talk about producers, distribution, but we very often forget the customer who is paying. And I try to take Ruth Ocon from Aachen University. She says good things have to work in equilateral triangle. You see in the green triangle. Wherever it's not in this combination, it's somebody is a loser. And compared to what we have at the moment, the customer just has to pay. Who has no chance to be a player. And that's why they also, I think, are against many grids. So if you're talking about team, it has been maybe a negative definition, like terror, aggression, or martyr. But I think for me, team should be together, everybody achieves more, so that we are coming close to the green triangle. But we are not only along with this green triangle, we also have a bigger system. And in between us a slide how it was done in the past with the ditches, where money remains. It's very expensive to put cables or pipes into the ground. And there is also a newer slide, because we changed our standard. You can say what is done to the ground. And if you want to put the overhead cables in Germany into the ground, we have 9 or 10 systems on a mast. And you say we have, each one has about 380 or 220 kilovolts, it can come up to a width of 60 meters. And we have to build 3 lines of 60 meters through Germany from north to south. So where no trees are allowed, no buildings are allowed, and that's the difficulties we have. So we are talking about the legislation, and in case we allow, let's say, trees close to the cables, we have to protect the cables. Gas is a bit simpler because there's only very often just one pipe, so we have about a safety area of 20 meters for high pressure gas. But coming back to the system, you see the old triangle in the middle with the users, the suppliers, and the owners. And we have the circuit called a supplied system. And we have some main influence and further influence from outside, which may make the circuit maybe to ellipse. But even then, the system is not alone. Let's take the square at the empty outer frame. So we have politics, the frameworks, we have the legislation, we have the environment, and we have the finance. And these outer influence, especially finance, makes it quite difficult to install new grids. So we would be quite happy to build the high voltage grids. At the moment, it seems to be stopped. But with the new minister, they call him Super Minister, Gabriel, well, he's starting today. We see and wait what will happen to our grids and also to our electrical supply, because I think everybody needs electricity. And if you think about a blackout, I don't like to think about it because it's my task. No food, no light, no money, nothing works without electricity. So we have to make sure that our grids are working and that we have good grids. So that was a very brief presentation to you. The original is about 80 slides, but cost to the time, I'd like to shorten it, and I hope I have taken you with me. And please do not hesitate to ask questions. So thank you to you, thank you to everybody. I'm still here.
Okay, thank you very much, Peter, for this presentation. It's not so easy to abridge a 80-slide presentation, but maybe that's the conclusion from what you've learned during the last 18 months since your presentation on the IRWA Education Conference in Seattle. A lot of things have happened here. We have new coalition here, new government in Germany, and as you've already told us, today we have also a new super minister on energy and economics, so it's quite interesting. That's what you've selected, and what still is valid today from your slides. Okay, are there any questions? I can see Bill Rose. You've shared the camera, so I assume you are going to ask a question. Please.
I do. Thank you, and a very informative presentation. Besides being in the water industry, I was in the gas and electric industry for 10 years, so a lot of what you're talking about I've experienced. What is the maximum voltage that you're planning to underground? Our experience locally is up to 500 kV undergrounding.
At the moment we have just 380, that's the highest voltage we have in Germany. And at the moment IRWA has a superconductor for about, I think it was 10 kilometers. But I haven't checked the voltage they have. They have the high voltage and they want to take out the medium voltage, so that they're going directly from high voltage to the substations to low voltage.
Right.
Well, it's an experiment. We have to wait and we see. So the voltage, the highest at the moment, 380 kW in Germany, as far as I know.
Also underground.
Yes, in our city we have a 110 kV line, which lies about 2 yards under the ground.
Okay.
You know, the other thing that you mentioned was the renewables with wind energy.
Yep.
Here in California, we have a mandate for 30% renewable as a mix in our energy usage or generation capacity. Mixing, it's predominantly made up of solar, some wind, and some geothermal as renewable sources. Integrating those renewable sources is proving to be far more difficult from a fixed system such as you have with nuclear plants, where the renewables come on and off the system.
Yep.
The Water Authority is pursuing a pump storage facility of 500 megawatts to try and help the San Diego region actually be able to fill in the gap when the renewables drop off and the fixed-base generation cannot come online as fast. So we're looking at startup times of 5 to 10 minutes for being able to activate the pump storage.
So we have these pump storage plants in Vianes, for example, in Luxembourg. We have some new ones, but we don't have the space in Europe to build very much of them. So they are thinking here in the rural area to put them into the coal mines. They are up to 1,500 meters deep. So it could be a very good storage. And the other thing we are thinking about is a power to gas and gas to power. So with the renewables, we can make hydrogen, and we have the gas system with methane. So we are thinking to make from hydrogen methane. We have the storage for methane, and then again from gas to power. Then we can run CHP plants to produce electricity and heat. So that would be a very simple way to store energy. And accumulators or batteries, I think it's more or less impossible. And the big power stations we have with the pump storage, Bianes is the biggest in Europe, which keeps the frequency in Europe constant. But space in Europe is a problem. I think in the States you have enough space, and it's a good idea to use it. Unfortunately, we have to go another way, but it's still better to use the renewables, even if the efficiency is a bit lower, than switching the wind turbines off. In former East Germany, we have days where the power of the renewables is higher than the highest peak of the consumption. So they are delivering the electricity to East Europe, and the strange thing is we have to pay them that they take the energy. So it's cheaper to switch the plants off at the moment. So I have taken that slide out of the presentation because it sounds strange paying somebody to take electricity.
No, it sounds very familiar to me. We anticipate that the renewables will be pumping during the day.
Yep.
In a pump storage environment, which is very unusual. It used to be that you were making use of fixed-based generation plants and that were underutilized at night, and that's how the original pump storage was used. So the renewables have added some interesting twists, and it's very interesting to hear how you're doing that. The coal mine option sounds very, very intriguing. Thank you very much.
Thank you for your question.
Yeah, thank you. So there's another question from Glenn Winfree. Maybe you can share the camera and ask it directly. Glenn.
Hi, Glenn.
Yes, how are you?
Fine, and you?
I'm fine. I was asking or thinking that it would be interesting to learn if there are any regional European plans for sharing infrastructure, maybe a high voltage DC line, that sort of thing.
Yes, it was in the past. It was standard. They built a DC line through the Baltic Sea, but unfortunately, at the moment, everything in the Western Europe is with AC, and just north of Europe, like Sweden, they have the DC. So we need the converters which are missing. And we have a very, very high density in energy. That's our problem. And to change the system, yeah, it's a problem. And even for DC, we need the space. We don't have.
Right. I have talked to a representative of a company that puts DC lines underground, and I believe their right of way is very narrow underground versus going overhead would take hundreds and maybe hundreds of meters, where it would only take maybe 10 meters underground. That's why I was thinking a crowded area might be a good idea.
Yeah, it's a good idea, and also these 150 papers which was presented last year recommend some DC lines, but the converters are missing. And as I learned from one power station, which was should be deliver the energy for the German railway, it's still not allowed to run. We have some problems for the converters because the railway is running with 15 to 30 hertz, and the other grid is with 50 hertz to find the converters. So again, from DC to AC, with all the systems that people have, it's quite difficult. And well, I'm coming from the steel industry. In the past, control with DC was much simpler than with AC. So what they've learned with all the trains, and they could go back to the roots with DC. Makes many things more simple. But who is paying? Who has the money? That's the question.
Always the question, yes. Always the money, yes.
Yeah. Unfortunately, I'm a technician, and we have many solutions, but we don't have the people who want to pay us.
Yes, we have the same problem on this side of the ocean, yes.
Okay, thank you very much, Peter, for this presentation. And so we come to our next speaker. It's Christoph Bennerscheidt. Okay, so our next speaker is Christoph Bennerscheidt, and Christoph is a senior research fellow at IKT, and he has initiated and worked on many research projects at IKT dealing with vegetation and infrastructure. He's also a member of a German governmental expert body on rainwater issues and member of the interdisciplinary German working group on vegetation and infrastructure. And he has prepared a presentation on research results and on some interaction we have experienced here in Germany between roots and underground infrastructure. And Christoph will present it now, and we share the screen with Christoph. Please. So we can see your screen now. Go ahead.
So there it is. Yeah, hello again from Germany. Now it's very dark right here, and I'm very proud to be here for the first time to make a presentation. And I have to add that I'm not only a member of IKT, I'm a member of IRWA since this year, and I'm very proud to be a member of this organization who is very open for all ideas. And so I will tell you something about our experience from root intrusion to conflict management. I pointed out as in this heading. And as you know, we started with a very small problem in Germany. It was very simple that we have some roots in the sewer systems, and we have to find solutions for that. And therefore, we started in 1998 a project. And in the same year, we had a German standard, the DIN 5060, where it was described what are root-proof pipe connections. And there it stands pipe connections of sewers and drains have to be root-proof, and the method to test root-proof defined in DIN 5060 is to prove the watertightness of a pipe connection under shear load. But we very fast found out that this was a logical argumentation for engineers, but trees don't read German standards. So I will now show you some pictures of roots, what they are doing in the ground in the city. Not actually the big transmission pipelines, but I have some pictures of what roots can do to oil pipelines, for example. We started with a small problem. We started to look at the bedding material where the roots grow very vividly, And Bert pointed out that the pore volume is the reason why they grow there, and that we have no problems with water, with the lack of water in the ground. And therefore they find trenches, and therefore they find the pipes, and they find the pipe connection. So we have several cases of root intrusion in pipe connection. It's one of the biggest problems in sewer systems. This is a detail of one of these pipe connections with an elastomeric ring, and there you see that this is a modern pipe connection, that they are able to enter the sewer pipes through these pipe connections. And we asked, can they do that? And we found it, for example, in a depth of 7 meters. So we have not only these shallow roots. We found out that the trenches of the private sewers that we see here, these orange sewers, they guide the roots into the deep, and possibly the untied sewers, private sewers that is responsible for the sewage that comes from the private house to guide it to the main sewer, is the one that is responsible for the aerification of this zone. And going international, we have some partners, for example, in Sweden, who make some trials built in 1993 and dig it out in 2004, and they found out that especially other materials like PVC and concrete pipes are also have an impact from root intrusion, and especially PVC is a material that doesn't seem to have the problem, because, for example, the Australian guys, the IRWA in Australia, made some tests with PVC pipes, and they found out that after 32 months of a test, no PVC pipes, for example, was penetrated by tree roots, but the other vitrified clay pipes and FRC, this is, I don't know exactly the name, it's fiber reinforced concrete pipes. They have penetrations after 32 months. So we are convinced that most of the pipe connections for sewer system have a problem when they are existing out of a spigot end and a gasket. Therefore, we made these tests to measure the root pressure. I think you know that we had a kind of small testing facility at IKT where we used plaster plate, put in, for example, there are some oak trees, and then we let these roots grow underneath the plastic plates and put out underneath these pressure-sensitive layers, and then we measured the contact pressure between the plaster plate and our pressure-sensitive film. And these are the slides that show that the roots are growing in this area. They have the secondary growth. That means that they are getting big, and after approximately 70 hours, we have a contact pressure of 11.9 bars. That means it's 1.1 megapascal. And we did that for different tree species. For example, we did the pine tree, the child tree, in German it's Araucaria, and the oak tree, and we measured different root pressures after different durations. Coming from the child tree pine from 4 bars up to the oak tree of 11.9 bars. And we don't know why there are the differences, but we measured it. But during the time we get an input from other utilities. For example, we have root intrusion into freshwater pipes. This is, for example, a freshwater pipe made from PVC, and the area where the roots grow in, this area where the pipe is glued to the connection, this area. At this point, it should be an elastomeric ring. There we have no root intrusion. It comes through this glued pipes, and possibly there was a leaking pipe during installation. Possibly the small roots lived up these glue pipes and find a crack then and grew in. And you see here, for example, in this area, this fine root materials that grows in the annular gap between the spigot and this, the gadget. One possibly other problem, it's another problem, possibly a bigger problem, the contact to gas pipes. This is a picture of Johann Wittmann from the city of Mönchengladbach, and these contacts to other utilities can cause different damages. In the easiest way, there's only some gas coming out of these pipes, and the network operators can smell it, like in this case, and build a new pipe. But probably it can go into private houses and cause an explosion, as it did in the 19th in the city of Viersen, for example. Then we have other problems with roots. Roots like the trenches, roots like the surfaces of pipes, and we have, when you have coatings, for example, with this bitumen material, some of these roots like the bitumen, that they get in contact with it, they have some acid that comes out of the root tips, and then they can destroy the coating, and afterwards we have the problem with the corrosion in these pipes. And this is, for example, a high pressure pipes. These are pictures from Clemens Heidgar of the city of Hanover. Or we have these cases that we have a concentrate load of oak root on these steel pipes, and for example this interaction can cause several damages to these pipes when wind load went into the road and then down to the pipe, and possibly can crack these pipes. And for example, in this case, either the root has to be pruned, or the pipe has to be laid to another position. And at least I have a picture from some oil pipelines from one company that runs an oil pipeline from the city of Rotterdam to the Ruhr area. And I got these pictures last year, and you see here the oil pipeline, you see the corridor that's normally protecting these oil pipes, but when you look in a detail, the roots from these trees grow the way from the point where they are planted to this pipeline and get in contact with this oil pipeline. And these oil pipeline too, like the gas pipe that we saw some pictures before, has bitumen around the steel pipe, and the coating, in this case, was intruded by roots. And again, there corrosion could be a problem, and when this corrosion is too big, it can, of course, cause a big problem when this pipe is leaking and oil is coming out. So normally, as an engineer, we have to say roots are a problem, because they are growing everywhere, in trenches, defects, pipe joints, lateral connections, and surface of different pipe materials. And normally, we have to say, no trees in the city. That should be the could be one solution of the problem. But as Bill Rose pointed out, trees are not only causing problems, they have some benefits. For example, when we talk about shadow, we are talking about oxygen, and when we can create a win-win situation, as it is described, for example, there. Imagine if trees gave our Wi-Fi signals, we would be planting so many trees, and we'd probably save the planet too. But too bad, they only produce the oxygen we breathe. When we create this win-win situation in different ways, I think we can be successful in the future. And therefore, I will show you this small example. It's an old example that we often discussed in our working group, and it shows the problem in cities when you have to find new corridors for utilities. Normally you use a pedestrian for this case, and on the left side you go along the pedestrian and put in, for example, a gas pipe or a water pipe. But normally when there's a tree in directly near these pipes, you are not able to build them in, because roots are growing there and roots are growing there, so you normally have to go into the middle of the streets. But Klaus Schröder has this example during his work in the city of Osnabrück, and he says, okay, let's have a look what happens directly beneath the trees when we dig it up by vacuum excavators. And this is a situation in the on the pedestrian way. Of course, there are the trees in the pedestrian, and there's no chance to lay the pipe without working in the direct root zone. And when you prune these roots, the problem will be at the tree, and possibly we have not only to prune the roots, we have to prune the branches of the tree, or we have to cut the tree down to lay the utilities. And therefore we looked at the other side, and there we found no roots in the street, and that was one of the big examples how we can manage the utilities in the street, that we can find corridors just by looking in the first time, and when we didn't find any corridor, we have to talk about that. This is then the new corridor for the utilities. In 2007, we put it all together into a symposium, Trees and Underground Pipes Busting the Myths. On the picture you see some participants from Great Britain. This is Don Richards from Thames Water. This is Bianes from IRWA. This is Örjan Sor from Sweden. And in 2007 we had the solutions for that, but we haven't got a basis to talk about the topic to other utilities. And therefore I think it was the right time to start the work of our working group to revise a standard, an old standard from 1989. In Germany, Bäume, unterirdische Leitungen und Kanäle. Translated into English, it would be trees, underground utilities and sewers. And I think it was a unique thing that we have there different participants from gas, sewage, road construction and urban green, who try to find a common language, how to work with this topic. And it was based on of our results from the research projects. So in February 2013, the interdisciplinary leaflet was published. It was after 7 years of work. Bert Bosseler, he is the speaker of the group, and Peter Lampret and we are members of this group. And you now get it from the German Association for Wastewater and Waste in Germany, from the German Association for Gas and Water, from the German Association for Streets, for example, and FLL is for the green part of people who works in Germany. They are planting trees and they're caring for them. And additionally, we have the German Society for Trenchless Technology, the GALC. These are the head of the departments of green in Germany, and FNN for electricity, and therefore it's, especially Peter Lampret is a member of it. Now I will show you only 2 points from these leaflets, and because we described different protection measures, we described active and passive protection measures, and these are just 2 examples how we can work together. The objectives of active protection measures are to construct and optimize specific volume for roots, to foster root growth in these specific volumes, and to limit root growth to these specific volumes. And the methods how you can do it is to create tree pits, to create root trenches, and to aerify these tree pits and root trenches. Some examples, what have been done in the past. This is one example from the city of Osnabrück. When you decide to plant trees, for example, directly beneath the lanes of a trees, you normally don't have enough place for the roots. They can only grow in this small trench, and there they created a big room underneath the streets. It's a very massive construction, but it works. It's still a nice street to go along with the car, and in the middle you have these big trees now. A second possibility is from Osnabrück too. This is under a parking area. You have really big possibilities to do the work, and this is a combination of tree pits and root trenches. And as you see, if there's someone who has the power to manage the trees, he's really building big tree pits and big root trenches. And in this area there will be the place for the trees to be planted, and the connection of the different tree pits. These are the root trenches that are the connections between different tree pits. And when you think in a same dimension for the city of Stockholm, they do it in this way. They are building big root trenches between the different trees, and in addition they use the stormwater from the surface to put it into the ground and to store it right there. And I think this is a possibility to create a win-win situation for stormwater management and for the trees in a crowded area in the city of Stockholm. On the other hand, we have some passive protection measures. They are in direct vicinity of underground utilities and sewers. The easiest way to implement passive protection measures would be during pipe installation in open trench. These things are the methods that I described in our leaflets are bedding material with a low pore volume. This is, for example, what Bill Rose is doing in San Diego when he uses the liquid soil. We have layers and plates to guide roots, but we still don't know how they really work. And you can use root-proof pipe connections, for example. And the reason why we look at the material with a low pore volume are some tests that we did in very small scale. We only used bentonite and we used garden soil, and we looked how roots of a willow grow there, and we found out that especially these areas with a very small pore volume in this soft bentonite were not intruded by tree roots, and therefore, for example, we wrote it down into our standard. Therefore, possibly Peter took this chance and used liquid soil with a low pore volume to protect his gas pipes where he directly planted some trees on. So it is possible to find solution in the crowded areas of cities when you look at some details how to create the properties of trenches, for example. And I think this is a possibility in the future to get more green into the cities and to lay new pipes. Therefore, we started at least a project where we will test bedding materials with a low pore volume, and the idea is quite easy. We have some trees, we have some trenches, and we put in different materials. On the left side substrate, on the right side the bedding material with low pore volume, and then we'll look what happens there. If this bedding material really is protecting our pipes, because it could change the properties, for example, by shrinking. There are some cracks that can occur during the time, and therefore we made a little bit bigger testing stands by planting big trees, as you see here. And these are the responsible people for this project. For example, this is Professor Stützel from Bochum, Klaus Schröder from Osnabrück, Mr. Brickwede, he is the head of the German Environmental Foundation. This is the mayor of the city of Osnabrück, our CEO, and this is Peter Heidenreich. He works for the German Environmental Foundation, who financed our test facility. And there it is. We planted these trees, and actually we finished this new planting, and now we can test different materials. These are our partners that supported us during the test, and we found some pictures, for example, what happens when trees enter trenches and getting connections to connection to different layers and plates. And these are the pictures that we get from that, and you can see that the roots are growing along these layers and plates, and it would be a big advantage to get more information about that, because layers and plates are used to protect pipes against root intrusion, and possibly these roots are only guided along the layers and plates and find their way into the trenches again, possibly after a longer time. One idea that we discussed is to make a win-win situation in the trench. For example, to use bedding material along around the pipes, and to use substrate with a high pore volume on the upper part of the trench, so that you have an area for trees, for roots, and you have a method to protect the pipes. Of course, you have to define what happens when you have a problem with a pipe, that you can work with a substrate. But we are convinced that the number of trees will increase when you find these solutions. So as a conclusion, the leaflet Trees Underground Utilities and Sewers published by these different organizations described the interaction between vegetation and underground infrastructure. And it has a scientific and practical background now. And the most important thing is, for me, we found a common language for engineers, landscape architects, and city planners, and this is important as a basis for an interdisciplinary conflict management, and possibly for not only for an interdisciplinary, but a transnational conflict management. And this is what I want to say, and hope you have some questions for me.
Thank you very much, Christoph, for your presentation, and I can see that Bill Busch has already some questions. Please, Bill.
Well, not so much questions as to say, when Christoph, you presented this at our IRWA conference a couple years ago, it was a most well-attended session, and there was lots of interest in the research of how to integrate the vegetation with the trench zones. And that interest is still very bright in the United States, I think.
Okay. Yeah, it was a presentation we gave together. It was a great deal to do together with you.
Then let's take a look ahead. On 13th of January, we will meet for the last time during this webinar series, and that's a great opportunity for all of us to wrap up our conclusions and to discuss perspectives for cooperation and even for joint projects. To prepare this very important session, you will receive a questionnaire within the next days. On the basis of your feedback, we will prepare an overview of conclusions and options. So this was certainly a very interesting webinar session today. We had great presentations from the US, from Bill Rose and Vic Bianes from San Diego County Water Authority, and also from Glenn Winfree from Duke Energy. Thank you very much for your contribution. And I'd also like to thank Bill Busch from IRWA for supporting this webinar by moderating this session with me. And also many thanks to our speakers from Europe, Peter Lampret from Energie and Christoph Bennerscheidt from IKT. But above all, I'd like to thank all of you for participating and for your questions and contributions. So I hope we meet again during our next webinar session on 13th of January. Once again, it's a Monday, then starting 2 hours earlier than today. It'll be at 9 a.m. Eastern Standard Time or 1500 Central European Time. Now I say goodbye to all of you, And you can see that today it has been proven by our speakers, even if it's already late here in Europe, the sun has just been rising in California. So goodbye.